Hi, guys. All right, this is actually, and I feel like we need like a big, ladies and gentlemen, this is our last official lesson for pre-calculus. Where's the applause? Where's the applause? Where's the fireworks? I don't really have a fireworks like. But imagine this will be our last notes. I'm still going to have like another video to shoot at you when I do a review for our test for next week. But guys, this is our last official lesson. Okay, we are finishing up day 4 of our section 16-3, where we're talking about tangents and tangent lines and slopes of tangent lines and slopes of curves. I'm super excited of all the fun math that we're doing. Today, we're going to do like an application question, which is like pretty amazing and super fun. So let's talk about that. Let's dig right in. Okay. So we are doing our 4th day of section 16-3. And so this is our 4th day. So we're still talking about tangent to a curve, but we're going to talk about an application question when we talk about our tangents. Okay. So there's really not that many slides today. There's just sort of like 2 slides. One of them is like a note slide, and then one of them has just one example. There's a part A and a part B, but so straightforward. But this is an application of what we can use this like the slope of a curve for, or, you know, where we're taking the limit of a secant slope. Okay. So physical quantities can also be found using this idea of a secant becoming a tangent. Okay. One of these fun sort of like connections is this idea about an average rate. Okay, these words right here of average rate. Let's see if we can get the pin going here. Okay, this average rate word is going to be similar to taking like a secant. Okay. And so if for a secant, it's just the regular slope of a line, like legit, like just doing y2 minus y1 over x2 minus x1, or really like in the function notation, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Okay, an average rate of change would be finding the slope of a secant. Okay, something that says, this is a different word, it says instantaneous rate. Okay, so something that's an instantaneous rate is similar to a tangent, where you're going to take the limit of the slope of the line. That's what we've been practicing so many times during our unit this time, right? Right? Is this limit of the slope of the line. So that's what it's going to mean if it says instantaneous rate. That's what you're going to do. You're going to want to find the limit of the slope of the line. Okay. So let's look at a very popular application, and that is velocities. Okay, if you're in physics, you've heard about position and velocity and probably even acceleration. If you're not in physics, that doesn't matter, right? I'm introducing the concept right now. So a velocity is a rate. So if you think about like you're in your car and you're driving along, okay, you'll have a certain like miles per hour. Okay, maybe you're going for a swift walk because you know it's so very important to get out and exercise, right? During this time of quarantine. So you have a certain rate that you're walking, okay, a certain velocity. So velocity is in fact a rate. So a position function, and they usually use the letter T to have like a time aspect to it. So a position function would be an f of t as opposed to an f of x, and it will describe a path that something takes. Okay, so those fun facts right there are going to come into play to our example. Okay, so we've got all of that written down. If it asks you for average velocity or an average rate, you're just going to do regular old slope. If it asks you for instantaneous rate or instantaneous velocity, then you're going to do the limit of the slope. Let's do an example. Let's do it, guys. Okay, so this says, we're just going to do example. Oh, I guess it's example 4 because it's a continuation from something else, but I guess it's example number 1. Okay, so it's our only example for today. It just has a part A and a part B. So I'm just going to scribble that out and make that be a 1. You're welcome. So it says the motion of an object is given by this function, f of t, right? So notice there's a t in there now instead of an x. I know, exciting. And it says t squared minus 3t plus 5. Okay, where f of t is the height of the object in feet at a certain time, seconds. Okay, what is the average velocity of this object between time equals 2 and time equals 2 seconds and time equals 4 seconds? Okay, so notice a couple of things. They told us about the average velocity, right? So that guy right there, average velocity, is important. We know that we're just going to do regular slope. Okay, it's also nice that they gave us 2 time values, right? So this is like your x sub 1 value, and then this is your other time value, which would be like your x sub 2 value. Okay, so we're just going to do regular old slope of the secant. Normal old y2 minus y1 over x2 minus x1. So it's going to look like this. For these particular values of 4 and 2, we're going to do f of 4 minus f of 2 all over 4 minus 2. Y values subtract over x values subtract. So now where am I going to get the numbers for f of 4 and f of 2? Oh, just right here from the equation. Okay, so I'm going to plug in those values and see what I can come up with. So a 4 squared is a 16, minus 3 times 4 is 12, and then plus 5, so 16 minus 12 plus 5. And then minus, plug in 2. 2 squared is 4, negative 3 times 2 is negative 6, and this plus 5. And then now, guys, it's just a matter of simplifying this, okay? So that it wasn't even that very hard, right? You're just plugging in the numbers, and then now we're going to simplify it. I know, right? Like super fun. So let's go ahead. Let's see. 6 and minus 12 is 4. 4 plus 5 is 9. Then we would minus over here. This would be a 9 take away a 3. 9 take away 3 is 6. 6 divided by 2 is 3. We need to put a label on here. Okay, we are talking about velocity. We were walking or this object. Sorry, we weren't walking. So silly, Mrs. Zach. She was thinking about getting her exercise out here in quarantine. Okay, and we were talking about, it said that the height of this object was in feet at a certain time second. So a velocity is going to be feet per second, and 3 feet per second is our answer for the average velocity. So just one more time, average velocity is like straight slope. Okay, if there was another rate that they said and they asked for the average rate, then again, you would just do regular old slope, the end, have a nice day. Oh, I love it. So fun and gorgeous. Okay, let's go to the next example. So part B now says, what's the instantaneous velocity, right? So this is a different thing, you guys. Okay, so now it says, what's the instantaneous velocity? And you will notice something. They only gave us 1 time value. Okay, so this means we're not doing the slope. This means we have to do the instantaneous rate, which is going to be the limit of the slope. And it's only 1 x value, okay, or 1 t value, excuse me, the t value. And so it's going to look like this time, the slope of the tangent. So if we remind ourselves how to find the slope of the tangent, it works like this, okay? You're going to do the limit. Oh, this looks so familiar to stuff that we did in our previous lessons, okay? So the limit as t approaches 2 of f of t minus f of 2 all over t minus 2. Okay. Let's be real for a second. What if, for some reason, you decided to put X's instead of T's? Guys, it's going to be the same thing. It's not a big deal. It's not a big deal. Okay, like actually and truly, it's super not a big deal. However, we are talking about a time, so I would prefer if you put a T value, but it's not the end of the world if you accidentally put X. Like the world will still continue. It'll be fine, okay? So we're going to write the limit of the t function. And so the limit as t approaches 2, f of t is t squared minus 3t plus 5. F of 2 was 3. How did I get that? I just plugged in 2, right? So it was like 9 minus 6. Nope, that was a lie. Shoot, it was right here. It was 4 minus 6 plus 5, and then we got 3. So I get t squared minus 3t plus 5, and then minus 3, because 3 is the value of f of 2 all over t minus 2. Now, guys, this happens just like it did before. If you plugged in 2 right now to the t values, it will become 0 over 0. We definitely don't want that. So what did we do? Oh, yeah, I remember we worked on our algebra powers, right? And we went ahead and we did some sort of simplifying so that we could get this t minus 2 to cancel. So I'm going to do a combo real fast, okay? This says, get this message off my screen. Come on, screen. Where's my mousey mouse? Okay. So it says the limit as t approaches 2 of t squared minus 3t now plus 2 all over t minus 2. And then probably this guy up here is going to factor. Does anybody want to take a random guess about one of the factors is going to be? Anyone out here? Anyone? Oh, no one's volunteering. That's okay. I'll do it. Yes, Mrs. Fox. I think one of the values, one of the factors is going to be t minus 2. Yes, that is totally right, Mrs. Fox. You have got it. it's going to factor into a t minus 2 and then a t minus 1. Okay, that's going to be on the numerator. On the bottom is going to be on t minus 2. It's still going to be the limit as t approaches 2. I'm going to cancel my t minus 2's. All that I'm left with is the limit as t approaches 2 of t minus 1. Finally, I can plug in 2 without it self-imploding. When I plug in 2, I just get 1. Now, folks, we're still talking about a velocity. Okay, a velocity, whether it's an average velocity or an instantaneous velocity, needs a label on it. So this is going to be 1 foot per second, and that, ladies and gentlemen, is it. What a beautiful answer. Okay, ladies and gents, that's it, okay? So just to remind you, if it asks for an average velocity or an average rate, you do the regular slope. If it asks you for an instantaneous velocity or some instantaneous rate, you're going to do the limit of your slope formula. Ladies and gentlemen, you are going to go and you're going to do some classroom exercises. What I thought I would do, since this was our last lesson, is that I would give you 2 of these questions that we just went over, okay? And then we're going to go back and review and do these classroom exercises that kind of like covers the gamut of what we've done in this section 16-3. Ladies and gentlemen, that's the end of notes. Oh my goodness, how exciting is that? Okay, so this will not be our last video. I feel like we need some applause. Some applause. Yes. Okay, this will not be my last video. I'm going to do the review worksheet that we have next week. Just as a reminder, we're only doing 4 lessons this week. Okay, so just 4, which means Friday is your day off. So exciting. So Friday is going to be your day off. Maybe use that day to catch up on some things that you may not have turned in. That's a great idea. And I think that's it. Okay, guys, until next time, I hope you have a great day. I hope you're doing all your homework on time. I hope you're studying for your AP exams. You're doing all sorts of diligent work and being a great, great, great student. I think that's all. I will see you when I see you. I miss you. Have a great day. Bye, guys. See ya.